Today we're dealing with nonlinear equations, sometimes quadratic and cubic equations is what we would call them. Quadratic equations are like this equation with the x squared. In other words, it has an exponent of 2. Cubic equations have an exponent of 3. Today, we're going to start by just graphing some basic cubic and quadratic equations as part of our teacher time. And then our together time, we're going to start synthesizing, coming up with some ideas that we have about cubic equations and quadratic equations and what they look like and what they should look like. Okay? So we're going to start by just doing this with plug and chug. We're going to plug in negative 3, negative 2, negative 1, 0, 1, 2, and 3 for this equation. It's important, and this is one of the reasons, remember I talked about always wanting to have numbers on both sides of the y-axis, negative numbers and positive numbers. That's not as important with lines. That's super important when it comes to these nonlinear equations. So notice that I am picking positive and negative numbers. All right, so let's go ahead and fill this in. We're looking at our equation is negative 2 times x squared, so I'm plugging in negative 2 times x is negative 3 squared. Negative 3 squared is what?
6. I can tell.
Negative 3 squared is what, Liana? 9. So that's going to be changing to a negative 2 times 9, which means our y is actually equal to negative 18.
Oh.
Next one, negative 2 times negative 2 squared. Starting with the exponent, negative 2 squared is
4
times the negative 2.
Negative 8.
Negative 8. Negative 2 times negative 1 squared. That's negative 2 times 1, which is negative 2. Negative 2 times 0 squared. That's negative 2 times 0, which is 0. 0 times anything, 0. Coming down to the next one, we have negative 2 times 1 squared. 1 squared is
2, or 1.
Positive 1. We have negative 2 times 1 is negative 2.
8.
Negative 2 times 2 squared. 2 squared is
4.
Times the negative 2 would be
Negative 8.
negative 3 times 3 squared. Negative 2 times 9. Negative 18. Okay, let's graph it. Negative 3, negative 18. So that's over negative 3. 1, 2, 3, and down 18. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Next was negative 2, negative 8. So that's over backward negative 2. 1, 2, and down 1, 2, 3, 4, 5, 6, 7, 8. And the next one was negative 1, negative 2, over negative 1, down 2. 0, 0. 1, negative 2. That's over 1 and down negative 2. Over 2 and down to negative 8. And over 3 and down to negative 18. So once again, just like on our do now problem, we see something that's definitely not linear. So we have this quadratic, this x squared function, x squared equation, that again makes this u shape. However, this u shape is just a little bit different. What are two things that are different about this U shape? Number one, it's down. And number two,
Oh, negative.
think about the width of it. It's much more narrow, okay? So this equation is a little bit different. It does have an x squared term, but something's happening with it that's changing it to flip it upside down, and something's happening that's making it more narrow. So we're going to talk about that more as we move forward. All right, coming over to the other side. This one's going to be a little bit more difficult, so you need to be a little bit more focused here. We're going to plug in -3, -2, -1, 0, 1, 2, and 3. So our equation is 1/4 x cubed. So that's 1/4 times -3 to the third power. -3 to the third power. We've already actually done this one kind of today, I think. Or did we? No, we did -2. -3 to the third power, Frida, is -27. So that's 1/4 times -27. Is that going to come out as a whole number?
No.
No, that's going to end up giving us -27 over 4. And in this case, I do want us to go ahead and do that division. Go ahead and do that division, -27 over 4. Find the decimal for me.
Negative.
So Patrick, what should our y be? -6.75. All right, so now we plug in -2, 1/4 times -2 cubed. 1/4 times -2 cubed. We actually have done this one today. We did an undo now. -2 cubed is
4. Or, no, 6.
-8. -8 divided by 4, or -8 times 1/4 is what? Jordan? You were a lot closer the first time. Frida? -8 over 4, which is 8 over 4 is 2, -2. Plug in 1/4 times -1 cubed. Yes, Joel. So it's a curve, so a straight edge won't really help. Straight edges help with lines. So probably not today. -1 cubed is -1 cubed is what? 1 times -1 times -1. That's 1 times -1, which is -1. So that's -1 times 1/4. That's -1 over 4. So 1 over 4 as a decimal. It's one that probably most of us don't need to do the division on. Jordan? So it's -0.25. One-fourth times 0 to the third power. That's 1/4 times 0 to the third power is 0 to the third power is? 0 to the third power is? 1/4 times 0 is? Yes, Michaela. We'll talk about that in a second. 1/4 times positive 1 to the third power. That's 1/4 times 1 to the third power is? 1 times 1/4 is positive 1/4, which as a decimal is 0.25. 1/4 times 2 to the third power. That's 1/4. 1/4 times 8. 1/4 times 8. That's 8 over 4, which is positive 2. And 1/4 times 3 to the third power is 1/4 times 27, which we've already done this division, should be a positive 6.75. All right, now let's worry about graphing. All right, so coming over to graph it, we've got -3 and -6.75. So that's over -3, 1, 2, -3 and down. -1, 2, 3, 4, 5, 6. And as I get to 6, I know -6.75 is going to be between -6 and -7. It should be closer to which one? Yeah, closer to 7. So I'm going to put my dot right here. It's not going to be in the middle. It's going to be a little bit closer to the 7. Next one should be -2, -2. Next one should be -1, -0.25. So that's down. That's going to be between the 0 and the -1. So maybe closer to the 0 or closer to the -1? Closer to 0. So I'm going to put my dot pretty close there to 0. Next one is 0, 0. Right there in the center. Next one is 1, positive 0.25. So that's over 1 and up 0.25. So that's going to be close to 0. And 2, 2. So that's over 2 and up 2. And 3, 6.75, so that's over 3 up. 1, 2, 3, 4, 5, 6. Closer to 7 than 6. So Kip yes or Kip no. Is this a linear equation? No, we can tell that from the graph. How else could we have known this was not going to be linear? Michaela? Because it has an exponent. So what this is going to make is this makes this nice little kind of curve here. Comes right through the center, starts curving back up. So your curve should look like that. Yes, Jordan? Not sure what you're asking. We'll follow up on that. Maybe after together time we can follow up on that. Okay? All right. What are the two things in the equations that are changing what the graph looks like? Yes, sir.
The exponent?
The exponent. So that's one of the things that's changing. The exponent is changing. What else is changing? Michael?
Whether it's a positive or a negative symbol.
Positive or negative coefficients.
Yeah.
So positive or negative, I'm going to rewrite that, coefficients. Coefficients. So those are the two things that can change our graph. And this is not too different from when we had linear equations. What changed the slope of the linear equation? How did we know if a linear equation was going to be positively sloped or negatively sloped? Maya. When we had linear equations, when it was y equals mx plus b, you're saying what changed whether it was positive or negatively sloped? It's thinking about nonlinear equations. Going back to linear equations, y equals mx plus b. How did we know by looking at the m portion of it, how did we know whether the slope was going to be positive or negative? Looking at this equation, y equals 2x plus 6. Is that a positively sloped line or a negatively sloped line? So it's the same thing. Y equals negative 2x plus 6. Positively sloped or negatively sloped? Negatively sloped. So it's the same thing with these equations. It's looking at that coefficient of x that's helping tell us something about what's going on. That's why that's kind of one of the things that we're really focused on. All right, let's make some generalizations about these families' equations, what the graphs are going to look like. Y equals ax squared. How can I draw that? Generally, what is that shape going to draw like? Maya? A U. So, in words, how would you describe it? Jordan? How would you describe this shape? A U. A right side up U. So if you remember that it's a U, one other way to remember it is it always makes if it's got a positive, it makes a nice happy smiley face. Whereas if it's a negative, it makes a sad smiley face. So that would be it wouldn't really be much of a smiley face, it would just be a sad face. So that would be a upside down and upside down U. Okay. One difference that you need to draw here and that you need to know is this is not a V. We talked about this before. It's not a V. It makes a nice curved shape. If you have it coming in at a point, that's a completely different equation that you'll learn about next year. Y equals ax cubed. So generally we see that those draw, here's a hint on drawing these. I always draw a half U on the one side, and then an upside down half U on the other side. So sometimes if you're not even good at drawing an upside down U, you can just flip your paper over. How would you describe this shape? Haseen?
Nervous face?
What? A nervous face? Okay, I can kind of see that. I like Desiree's description. The other description I get is a slide, so makes an S or a slide. And how is it different than the negative ax cubed? How do we know the difference?
It goes the other way.
This one goes up, so this is a slide or an S. that ends up. So it ends positively. Now a negative, we saw, ends negatively. It's got the same shape, it just ends negatively. So this is a slide, or S, that ends down. So we should be able to recognize any equations if we look over at the alone time work that we're being asked to do. So as we look at our alone time, what we need to do is we're being asked to look at this shape of this graph, and we should be able to know something about the equation of that shape based on what we've learned today. So it's saying which of these could be the equation for that. So looking back through your notes, you should be able to sort that out. And the second part is just being able to plug and chug, plugging in values for x to get your y values to graph this nonlinear equation. Okay, so